Hi, so today we're talking about square roots. But before we get to square roots, I think it's beneficial to talk about perfect squares. So if we take a number 2, for example, and we square it, what they're asking of you to do is take 2 and times it by itself. 2 squared is 2 times 2, which will be 4. So 2 squared is 4. And then we continue this, we go 3 squared would be 3 times 3. So when we square a number, we're multiplying it by itself. So 4 squared is 4 times 4, which is 16. 5 squared, 5 times 5, 25. And I'm going to speed through this because I bet you're seeing the pattern by now. If it's too fast, don't worry. The beauty of technology, you can pause this and write this down. 9 times 9 is 81, and 10 times 10 squared is 10 times 10, which gives us 100. These numbers here are perfect squares. And we're going to talk about why they're perfect squares in a second here. So if someone asks you to find the square root of a number, it would be written like this, the square root of 4. So the square root of 4, it's asking what number times itself is 4. Well, what number times itself is 4? That'd be 2. So the square root of 4 is 2. And then we continue here, the square root of 9. What number times itself is 9? Well, 3 times 3 is 9. So the square root of 9 is 3. You may notice at this point that the square root is undoing the square. If I was to write 2 squared and I square rooted it, this square root undoes the square. They are inverse. They have an inverse relationship. They undo one another. And we're going to use that to our advantage. So square root of 25 will be 5. The square root of 36, 6. The square root of 49 is 7. Again, if you need to catch up, pause the video. And there will be a moment where you can pause at the very end. So what's interesting about this? Okay, great. The square root of 4 is 2. Square root of 9 is 3. Well, why are they perfect squares? If we try to take the square root of 5, look what happens. We end up getting a decimal. A decimal that is in between 2 and 3. And the square root of 5, therefore, is in between the square root of 4 and the square root of 9. Then if we do the square root of 6, another decimal, a little closer to 3. Square root of 7, another decimal, again a little larger. The square root of 8, another decimal. And then we square root of 9, we get a whole number, we get an integer. So that's why these are significant. When we take the square root of perfect squares, we get integers. We do not get decimals or fractions. So these numbers here are perfect squares. There are more, of course. I stopped at 100, where we could have continued this on and on and on. We could spend all day doing that, but no point. So most of the perfect squares we need for simplifying radicals are these here. So the square root of 4, the square root of 9, we got 16, 25. And it's going to be useful to know these perfect squares when we start simplifying radicals. I would recommend that you copy this and have it set aside so when you're working on radicals, you can think, oh, what perfect squares are there that I can factor out of these radicals, which will be in the next video. These are your perfect squares.